Hello. Uh, yes, since so many of you are emailing me about the keys, about the key to the sample practice exam 2, here I make this little video. Hopefully, it will help you a little bit. Okay, for the first question, and this is a typical question as we did in the homework, right? So we have this many, actually 12 observations, right? And then as the temperature. And this R code gives us the length. That means the sample size is 12, n equals 12. And also give us the mean, the sample mean. We add these 12 numbers together divided by 12. And also SD means the what? Standard deviation, right? Give us the S. And then also we have the sum. This sum just tells us how many observations are over 15. Actually, we have 3. Temperatures are over 15. All right, now based on the information, then we calculate the first one, 95% two-sided confidence interval on the mean temperature mu. And remember here, because we know the sigma, right, the population standard deviation, that's why we have to use the z interval, the z alpha over 2, which for the 95%, which is 1.96. Okay, this is z. All right, use this red formula. And how to interpret this 95%? We could interpret this one as what? For example, if we have 100 samples, because here we have one sample, then we would have one interval, right? Just imagine we have 100 samples. We would have how many intervals like this? 100. And for this 100, about how many of them gonna contain the true mu? That's exactly 100 times 95%, which is 95. Okay, this is the right way to interpret this 95%. Part 3 is about how the sample size. If we want to be 90% confidence the error in estimating the mean temperature mu is less than, that's exactly the margin of the error at most 2. So we use this formula to get this one is about 1. Okay, of course, this is only just one example. Okay, so yes, this is a little tiny. All right, now if we do not know this sigma, but we know, of course, what is a good estimate for sigma? That's S, right? Because from the R output right here, that's S. This guy, this is S. Okay, so it's about this big. Right? So since the sigma is unknown, then for the 99% the two-sided confidence interval becomes this formula now. Okay, we got to be careful because we do not know the sigma. We have used t. That's why the critical value, the t value, becomes from the t table. Okay, and then we plug it in, we get this number, this interval. For a 99% upper confidence bound, this is also another formula, right? So it's right here. That's the formula. The difference between 4 and 5, part 4 and 5 is what? Is in 4 we have to split the alpha by 2, right? So the t value becomes this guy. But for the part 5, because this is upper confidence bound, so we have to use the whole alpha, because alpha in this case is 0.01. Okay, so that's the t value from the t table, and then we plug in. That's how we get this upper confidence bound. Now let's talk about the p, because among these 12 observations, we have 3 of them are over 15 degrees. So this proportion is about what? 3 out of 12, which is 0.25. And then based on this, what is the 95% two-sided confidence interval on the P? This is the true population proportion of temperatures that above 15 degrees Celsius. So that's the formula right here, okay, for the proportion. And as for the sample size, for the proportion estimation, we have 2 choices. The first one is part 7, which is because here we have the consider the information, right? Using this point estimate of the p in part 6, which is 0.25 a quarter. So if we use this information, this is the right formula to use, because we have to use this estimate of the p little p hat put at 0.25. So the sample size would be about 1801. But what if we say regardless of the p, regardless the true value of p, because here we do not use any sample information at all. Then the formula tells us this p we just put as what? As equals 0.5, which will give us the largest value, right? We're going to use this formula right here. That's why if we do not use the information, then we have to use a larger sample size, okay? This is 2401. It's about 1/3 bigger, okay? All right. So, and we can also use this information to estimate the population standard deviation, come up with a confidence interval. This is about sigma square. But here we be careful, because we are doing for sigma. That's why we take a square root on both ends, okay? We did this kind of a practice in homework 3. So that's the right way to do it, okay? And for the question number 2, this is about 2 intervals, prediction interval, right? So based on the level, this is the alpha 0.05, and then half of that is 0.025, and then degrees of freedom equals n-1. We got 24, so that's 23. Then we got a t, and then this is the formula. We plugged it in. That's how we get this one. Okay. All right. After we calculate the prediction interval, then we have to interpret this interpretation, because this is about the prediction about the future traveler, right? So we could use 95% chance. Why? Because how much time the future traveler will go through the security is a random variable. So we are perfectly fine to say 95% as a what? As the probability, as a chance. Okay? But if this is the confidence interval for the mu, then we could not just interpret this 95 as 95% chance like we did right here, right? Okay, this is the difference. So here we say, okay, we can only say if we got 100 samples, then we'll have 100 intervals, then we would say we have 95 of these intervals will contain the true mu. But for the prediction, we could just say, okay, the future traveler to the time the future ordinary traveler goes through the security has 95% chance to be in this interval. Okay, or you can say 95% probability to be in this interval. Okay, so that's the difference between the prediction interval and the confidence interval, All right, now let's say tolerance interval. Tolerance interval, we have to consider 2 values. One is the coverage, the first percentage, and then second is the confidence level, 95. So in our case, alpha is 95. 1 minus alpha is 0.95, okay? Gamma is 95%. We go to that K table, okay? We can get this K value as 2.651. And then we plug it in, use this formula. Here is still S bar, okay? But the only thing different now is what? Instead of use this T times this square root 1 plus 1 over n, we use a different parameter as a K value, which is from the K table. Okay? And then we end up with this interval. How to interpret this interval? this interval, first of all, is a confidence interval, okay, 95% confidence interval. As we always know that this confidence interval may not contain the 2 mu. It may contain the 2 mu, may not. Either way, right? So with the tolerance, we get an extra buffer zone. We just say, okay, now we just switch. You can see, take a look. For the 95%, if we just the confidence interval no, for the two-sided one, this number is only what? 1.96, right? But now we get what? 2.651 is much bigger. That means we make this tolerance interval bigger. We would make sure, in this case, this interval will cover 95% of the traveler's security check time. Okay, so here I put the middle 95 because remember the security check time is normally distributed, right? Is scattered around its mean. That's what we mean by the center. So we would guarantee this interval we calculated here would cover the 95% of those kind of security check time with 95% confidence. Okay, yes, this is a little complicated. I would strongly recommend you to the notes we went through in class or even the textbook, okay, in the chapter 8, if you have questions. Alright, the last one is about section 1 of chapter 9, about the basic setup of the hypothesis testing. So in our case, in this case, because we want to know whether this mu is less than 12 or not, right? That's why our alternative is mu less than 12. Of course, the alternative, the null hypothesis is easy, right? Mu equals 12. So obviously this is left-sided test because of what? Because of the alternative is this. All right, how to figure out the type 1 error probability? What is type 1 error? Type 1 error says the null hypothesis is right. That means mu equals 12, but we reject the null hypothesis. What is the rejection region? The critical region is defined as x bar less than 11. So that's why we need to figure out the probability for x bar is less than 11 given the true mu is 12. That's the way we figure out the probability, right? And then the rest is just to calculate the probability as we did before, okay? And then how about type 2 error? Type 2 error is what? The null hypothesis is wrong, okay? Mu is not 12 anymore. In our case, mu actually is what? 11.5. That means mu is less than 12. That means this guy is right. Take a look, right? Okay, and then since the null hypothesis is wrong, then we need to do what? We need to reject it, right? But the type 2 error is what? Fail to reject. Fail to reject basically says we want to know whenever the x bar is over 11, under the 2 mu equals 11.5. That's exactly the probability for the type 2 error, right? Because mu equals 11.5, that basically means the null hypothesis is wrong. X bar greater than 11, that means fail to reject the null. Okay, and then the rest is about how to figure out this probability. Okay. Yes, we spend a lot of time how to define the type 2 error, how to figure out the probability for type 2 error, and also how to represent the type 2 error into the chart. You can see right here, we have two normal curves. The first one on the right is the null, right? This is the null hypothesis, H naught. And then the second one is on the left, is the under H1 alternative. Okay, is the dashed curve. So because remember, the type 2 error is calculated under what? Mu equals 11.5. Basically says the alternative is right, or we can say the null hypothesis is wrong. So we have to use this dashed curve, and then x bar greater than 11, we cut off the point is 11, greater than is on the right. So that's why the beta, the probability of commit type 2 error, is gonna be this shaded part, okay? Okay, like I put it like this way, all right? I think that's all for this practice exam, and I hope this little video will help you a little bit. And if you have any other questions, please let me know. Thank you.